Okay, so this is a worksheet I got from, I don't know if you say it as Kuda, Kutta, whatever, but I did kind of change the instructions to focus more on some vocabulary you're going to see when you do polynomials. One of the things you're going to see is the degree, which is your highest exponent. Your degree should always be positive. The leading coefficient is the number that doesn't include the variable in front of the degree term, and then the constant is the number without a variable. I am right now debating with myself if I want to highlight all these a certain color, if I just want to show you where they come from. I might show you, then come back and highlight. We'll see what I figure out. Okay, so instead of naming each polynomial by degree and number of terms, I'm just going to go through those 3 vocab words. I don't want to write leading coefficient every single time, so I abbreviated it as LC. Commonly, degree will also be abbreviated as DEG, but I went ahead and labeled these to begin with. So I'm going to move it up so you can maybe see it a little better. Wait for my camera to focus a little more. There we go. Okay, when you just see a variable, and there is nothing in the exponent, like there's nothing up here, you can go ahead and put like a 1 right there. So if there is no degree, but there is a variable, it's going to be 1. So the degree is 1. The leading coefficient is going to be this number in front, not including the x. So that's going to be -10. And I don't know if that's that's a mark on my paper. Yeah, it's a mark on my paper. Okay, so it is just -10. And then my constant doesn't exist. So what could you add or subtract that wouldn't make a difference? Well, that's going to be 0, because this -10x is the same as -10x plus or minus 0, whichever. Okay. Over here, your highest is 4. Your leading coefficient is again -10. And again, the constant's going to be 0. When it is just a number, there is no variable. Well, the constant is 7. The degree, it's going to be a little weird, okay? So you can rewrite 7 as 7x to the 0th power, because anything to the 0th power is 1. So anything to the 0 power equals 1. Doesn't matter if that's 1 million, 1 billion, whatever, it's 1. 7 times 1 is still 7. I would say the degree is 0. And I can be quite honest with you, when I say I don't know what they would want you to mark the leading coefficient as, I don't think it's very common that you're going to see something like that where you need to mark the leading coefficient. If you want to look it up, like I'm going to at the end of this video, you definitely can do that as well. Number 4 is really good to kind of see like a larger expanded version of it. And then after that, I'm going to point out something about number 8 and then pause it and kind of let you all do your own while I finish filling in the answers. So because I did go in descending order, my degree is 6 because that's my highest exponent. My leading coefficient is the number in front, which is 9. My constant is also going to be 9 because it's a number without a variable. So don't get those 9s confused. The thing to notice about 8, I did switch it into standard form, meaning I have my highest exponent first and I work my way down to my constant. I like doing that because it is easier to see my degree, my leading coefficient, and my constant. And I am so sorry, my toddler does not want to go down for bed and her father needs to turn down the monitor right now. So I would rewrite like this. I did kind of point out what you're looking for, but that will help. So pause right here. If you don't have this worksheet at home, I mean, it is a free worksheet online, but if you don't have this worksheet, take some time, write down what you see, and then go ahead and fill that in. I'm going to pause right here, and I'll come back with it filled in. Okay, so here are the answers for the ones we just talked about, making sure when there is no constant, it's 0. If you see just like an x squared by itself, which you don't in this example, but if you just saw like x squared plus 4x minus 5, then your leading coefficient is 1. When you don't have an exponent, the degree is 1. If you don't have a constant, it's 0. So just a couple things to remember. I know there's going to be more that I am forgetting to say right now that I'll come back and say, but for now, that's all I got. Double check your answers, and then we're going to go into combining like terms. Okay, so when you are combining like terms, they have to have the exact same variable with the exact same exponents. So when I look at this first one, what I did is I looked at it being addition. Well, when you multiply anything by a positive times a positive is a positive times a negative is still a negative. So this does not change any signs in the following parentheses. So in the first step, I just removed the parentheses, and then I reordered in standard form. So I have my highest exponents first and then my way down. And I grouped them together because they have to be the same. Now, normally I would color code this, but because of the glare, I just want to make sure that we can see it. Maybe I'll come back and do it as needed. So these two are going to combine, and so are these two. 4 plus, and if you need to pop a 1 in there, do it, because when there is nothing, it's like 1. 4 plus 1 is going to give you 5, and then you leave your exponent to the fourth. When you're adding and subtracting, you do not change the exponents. This is like a -1, and a -1 plus 5 is the same as 5 minus 1, so that's going to give you 4. And again, you leave it alone, you're going to do squared. Now, because of the paper and the size of my camera, I'm not going to go to 11 and 13 quite yet. I'm just going to pop down here to 12. Same idea where my positive is not going to change these signs. So I just took away the signs, grouped them together by what can be combined. Now this 7x cubed is the only 7x cubed, so it can't be combined with anything, and I'm going to leave it alone. 3 plus 6 gives you 9. 5x is by itself. And sometimes I do this where even if it's by itself, I still give it a different like symbol, especially if I'm not using highlighters. You can do this, you don't have to. And then this 5 minus 12 is going to give you the -7. Now for 11, this negative, what's technically happening is you are distributing a -1, and so negative times a positive gets a negative times a positive is another negative, and then I did the same reordering as earlier. This is like 1 minus 3, which is going to give me -2. I don't mess with the x to the fourth. 5 minus 4 is 1. So here's the thing. You can write it that way, or if you want to put the 1 in front, I'm sure whoever's teaching doesn't care. They might have a preference, but it's not wrong either way. 13 is a little longer, but again, we're back to this positive, which is not going to change any of these signs. -12x to the fifth. Nope, it's a positive. There's something on my paper. So 12x to the fifth, I'm not going to move. I'm not going to combine with anything. There are no other 12x to the fifths. Some of y'all will definitely be able to skip this step and go right here, or you'll start combining and you don't even need to write it all out. Try to show some work. I know as a teacher, it is easier for us to see where you went wrong when we can see your steps so we know how to help you. So I have 8 minus 7, which gives me this 1. I personally don't write the 1, but you can. 3 plus 6 is 9. And then I have my +4. If you want an extension on these as you're going, like what we did up above where you list the degree, leading coefficient, and constant, this would be a really good extension for that. But I'm going to go ahead and flip over to the other side of my paper. We got a couple more combining like terms before we get to multiplying. Okay, so this has quite a bit going on, and I didn't think things through when I started like showing the distribution, so I did kind of cut some space. But these are really good to show you that they have to have exactly the same variables and exactly the same exponents. So m to the fourth, I have 3. I have 13 minus 2 minus 5, which is going to give me 6. And I'm actually going to write it over here just because I don't have a lot of space and I want to make sure I have room. So I have 6m to the fourth. These 3 are done. They're taken care of. M to the fourth n squared. Well, this is m squared n cubed, so I cannot combine these. They're going to stay by themselves. But I can combine this 2 plus 2, which gives me 4. And that's going to be my answer. Something to make note, when you see this, anything that follows the subtraction sign is going to distribute and change your signs. That happens twice in this next one, so I already went through and changed the signs. If you find a mistake, it's going to happen. You're going to drop negatives. It will change your answer, so just be careful of that. So mn cubed, I have 3 of those. I can combine those 3 because they all have a singular m and they all have 3 n's. So negative 10 plus 7 gives me negative 3, minus 6 gives me negative 9. So I have negative 9 mn cubed. I can combine my n to the 4th, which is going to give me negative 2n to the 4th. And then my just n cubed should be 1. Now normally I go in alphabetical order and I go like my highest m's down to my lowest m's and then my combined terms, and then I go up with my n's and then I go to my constant. That's just a me thing. I genuinely don't know that I've seen it any other way. This one did throw me for a loop because there were no m's, there were no constants, and I didn't know how I quite wanted to order these. Normally, I think I would switch these two around and go like the other order, but that's not like a requirement at this moment in time. Okay, so let's talk multiplying. When you're multiplying, this is when you do change exponent values. You don't when you are adding and subtracting, but multiplying is weird because you will end up multiplying and adding and subtracting. So it's a combination of a whole bunch of different things. 2 times 1 is 2. N times n is going to be n squared. 3 times n is nice because it's just 3n. 2 times negative 2 is negative 4, and I got to pop that n back in there. 3 times negative 2 is negative 6. If you haven't watched my other videos on multiplying, this is called the area model because it's like length times width that you're multiplying. It's really nice to organize. You can still use distribution and split it up that way. I think this helps organize, especially if you're a color coding person, you can do that. Or you can just look at your diagonal. That's not going to always be the diagonal, but quite frequently you're going to be able to combine like terms. So as we previously talked about, combining like terms, they have to have the exact same variable, the exact same exponent. This is an n squared. We don't have any more of those, so I just have 2n squared. But I have a 3n and a negative 4n, and then I have my negative 6. So when I look here, it's now just like the practice problems we did prior to this with adding and subtracting, and I can simplify a little more. So 2n squared minus n minus 6. I can put that 1 there. I don't have to. Over here, it's the same idea. All of these are the same. They're just different letters. 4 times 5 is 20, and then I'm going to have my v squared. Negative 1 times 4v is negative 4v, 15v, and negative 3. Again, looking at this diagonal, they're both a singular v, or if you write it all out, you can see it that way. The order of how you write it doesn't matter. I just try to keep my like terms together, and I try to go instantly into standard form because I think that's easier, but that's up to you if you want to do that last. Negative 4 plus 15 is the same as 15 minus 4, which is going to give you 11. And there you go. So looking at 18 and 19, those are really good practice problems if you want to try these two. I'm going to jump down to 21 and then 23 just so you can kind of see a couple different examples, and then you can do the other problems. And I'll scoot back over so you can make sure to see it if you don't have this worksheet before I pause it. The really nice thing about this area model is you can expand it. So we were doing 2 by 2s. This is a 3 by 3. The only difference is you're multiplying more things, but it's still going to give you all the same idea. So we got negative x to the 4th, 3x cubed, negative 5x squared. Negative times a negative is a positive, so I have 2x cubed. It's going to be negative 6x squared, 10x, 8x squared, negative 24x, and then a positive 40. So again, with these diagonals, and it does work nicely, I am going to highlight just so you can see it a little easier. With the 2 by 2s, it's not as important that you highlight or keep track, but here you can see that those two are going to go together, and I'm going to make sure you can still read it because that's important. These 3 are going to go together because they're all the squared. And then these 2 are going to go together because we have the x by itself and the x by itself. again, I am going to write this out. And I'm going to write it over here. Yeah. Okay. So I have negative x to the 4th, 3x cubed, and 2x cubed. And I don't have a lot of space because I drew it in kind of an awkward spot. So I'm going to come down and pop it over here. Negative 5x squared, 6x squared, 8x squared, 10x, negative 24x, and 40. Because there's 9 terms here, right? You had a 3 by 3 box, but you can combine. So your final answer is going to be negative x to the 4th. We have 3 plus 2 is 5, so 5x cubed. Negative 5 minus 6 is negative 11, plus 8 is negative 3. I still didn't write it far enough out. Minus 14x plus 40. So this right here will be your final answer. The reason I want to show you 23 is what happens when you have 2 variables. So you kind of saw it when we were combining like terms, but you haven't necessarily seen it when you multiply. It's kind of similar to when we had one, or what example? Up here, 3 times n gives you 3n. You kind of just like smush them together. The same thing's going to happen here. So 4 times 6 is 24, and you have a u and a v. I put them in alphabetical order every time. Sometimes what I see is I'll have students put like VU in one of these spots and UV in the other, and then they might struggle to realize that you do combine them because they both have a singular U and a singular V. That's why I just always put it in alphabetical order so I don't have to worry about the order and comparing. It's not wrong to put it in the other way if you want to say VU. Like it means the same thing. 2 times 3 is the same as 3 times 2. So U times V is the same as V times U. But you gotta be careful. I also don't like that they used U and V because they do look kind of similar. But I'm going to have 48 U squared. And see, this is what I messed up on right there. That should be a U squared. And then I'm going to combine my 24 and 48, which gives me 72. That's my UV both together, and my 24V squared. So this is what I was talking about earlier, where I have my highest U, my combined, and then my highest V. And again, just be careful of your U and V together. I just had to double check I did that right. So you still have 18, 19, 20, and 22 to try on your own. I would pause it here, try it on your own, and I will put up the answers here in a second. Okay, so a couple things to talk about. Being careful of signs. Unfortunately, if you mess up in one spot in this, chances are you're going to mess up in your final answer. I did not highlight, and I didn't write everything out. Just know that this 4 comes from 24 minus 20. This 34 comes from 30 plus 8 minus 4, and then I have my 6 plus 10 and my 2. Here, because it's the same numbers getting multiplied, it looks very similar. Just be careful with M and N. And then you can kind of see what I did for the others. The critical thinking questions I don't normally do, nor do I really assign to my students. Down here is a note about combining like terms. They have to have the exact same variables with the exact same exponents. This is what you've been doing. So A times C is AC, BC, AD, and BD. And that kind of helps you see how it works. I don't like this as well because you can't necessarily see what can be combined because you don't see the exponents and the variables. For this one, you can do a box for this multiplication part. So it's going to give you 12x cubed, negative 15x squared. But you can't forget that you have that 2x in front. So we have x cubed and 15x squared. So I'm going to start with my highest, which is my x cubed, and then my next highest and my lowest. I don't have a constant, so my degree is 3. My leading coefficient is 12. Say hello to the dog. And my constant is going to be 0 because it doesn't exist. And that's it. So you kind of got a preview of the degree leading coefficient constant, adding, subtracting, and multiplying.